Welcome to the deep dive. Today, we're embarking on a really exciting exploration. We're looking at how everyday folks, people who've maybe never written code, can use these digital allies.
You mean AI assistants like ChatGPT?
Exactly, things like ChatGPT, how they can help you build your own, frankly, incredible tools.
It's fascinating, isn't it, how these AI tools are kind of unlocking complex tech for
Yeah.
almost everyone. It's
Yeah,
not just programmers anymore who get to create these sophisticated digital environments.
totally. And our focus today, our deep dive, has a very specific pathway in mind. We want to map out the journey starting from, let's say, the familiar world of our studio, which is great for analyzing data,
Hmm.
all the way to actually building personalized interactive 3D GIS programs and
Yeah.
doing that inside popular platforms like Roblox Studio and Unity.
Right. So taking the insights, the geographical data stuff we handle in our studio, and turning that into, well, an immersive 3D experience.
Picture this. This is the aha moment for me. Turning these game engines basically into your own custom version of GIS software. Like, think QGIS, but in 3D.
Okay.
Imagine you could actually step into a landscape you've made, add features like buildings or rivers, name them right there in real time. Really get hands-on with your data, but in a virtual space.
So the question becomes, how can someone, maybe without deep technical skills, actually use this pathway? How can they create their own way of, understanding and interacting with their environment?
That's exactly what we're digging into for you today. We know you want to grasp things quickly and thoroughly and hopefully not feel bogged down by overly complex jargon. So let's start at the beginning. Our studio. That's where we can begin making sense of our geographic info.
Yeah, our studio is definitely a powerhouse,
Yeah.
known for stats and plots, sure, but it's also really strong for working with geographical data, making maps. It's kind of the perfect launch pad for this journey into 3D.
And what's really brilliant, I think, is the sheer amount of free open source stuff available within R. Packages like SF that helps you handle spatial data frameworks, think digital maps.
Right, vector data.
Yeah, vector data. Then there's ggplot2 for making really clear, quite beautiful maps, actually, and or Natural Earth, which gives you access to like ready-made global map data sets.
And these free tools are key. I mean, you can do a huge amount of GIS work without needing, expensive specialized software. It's all about making it accessible. And there's this massive community constantly improving things.
Okay, so let's get a bit more concrete. Say you have some GIS data, maybe shape files outlining land parcels or something.
Hmm.
In our studio, you can use a pretty simple command, sf.readsef. That just brings the shapefile data right into your R environment, like opening a file, basically.
Exactly. That's step one, get
Yeah.
your geo info into our studio. Once it's in there, you can use what's called the tidyverse. It's a collection of R packages built for data wrangling to, clean it up, organize it, get it ready for mapping or analysis.
And then to actually see it on a map, R uses the ggplot function. It's like building your map layer by layer. You add points for locations with gmplu, maybe draw roads or rivers with gmline, represent areas like parks or buildings with gmpolygon.
And the customization is fantastic. You can control colors, labels, line types, everything really.
What makes our studio so potent, though, is how you can blend the stats with the maps, right?
Absolutely. You're not just looking at a static picture. You can actually analyze spatial patterns,
Mm-hmm.
calculate relationships maybe between elevation and population density, for instance, and pull out really meaningful insights directly from the map data.
And we should definitely stress this. R and R Studio are completely free, open source, huge online community for support too. So if you get stuck, chances are someone's already figured it out. It really pushes towards, reproducible research.
Yeah, that open collaborative spirit is what keeps improving these tools constantly. It's not just one company, it's loads of users.
And if you need these specific tools, these packages like SF or ggplot2, you just type install.packages and the package name. Simple as that, like adding an app.
Very straightforward way to tailor our studio to exactly what your project needs.
We even saw, how you can make scatter plots on maps showing trends. Using gplot, again, with something called geomsmooth, you could analyze, say, altitude versus the number of households in different areas and see that relationship visually.
Yeah, visualizing those statistical links spatially gives you a much richer picture. You spot geographical trends you'd totally miss in just a table of numbers.
And here's where it connects back to our main theme, especially if coding feels a bit daunting. Even if you don't have a deep stats background or know R inside out, Those digital allies, the AI tools,
Right.
they can actually guide you through this. You can sort of describe what you want to analyze or visualize, and the AI can suggest the R code you need.
It's a game changer. Seriously lowers the barrier to entry. People can do complex analysis now without years of programming training.
Okay, so we've used our studio, we've analyzed, visualized our geospatial data. Now, the leap. How do we take that information, that map data, and bring it into a 3D world we can actually walk around in? What's the bridge?
Well, the core idea is that the information you've processed in our studio, the precise coordinates, the attributes associated with features, the shapes, that all serves as the foundational blueprint for building your 3D interactive scene.
So it's kind of like how GIS pros using, say, QGIS, which is often 2D, right? Use their data, like shape files or even raster data, like digital elevation models.
DEMS, yeah, the height maps.
Right, DEMS.
Yeah.
They use that data to build 3D models in software like Blender.
Exactly the same principle. The geospatial data gives you the where and the what. And the 3D platforms, in our case Roblox Studio and Unity, provide the tools to create a virtual 3D representation of that information.
Which brings us to Roblox Studio. Now, many people might just think kids' games, but it's actually this free collaborative design space. It has huge potential for creating digital twins, virtual copies of real places.
And surprisingly user-friendly, uses a scripting language called Lua. Makes it quite approachable for building interactive stuff.
So those 3D models you might have made in Blender, maybe using your RStudio data as a guide, you can actually import those directly into Roblox Studio.
Yeah, allows you to bring in detailed 3D buildings, trees, infrastructure, whatever features you want in your virtual world.
And you can even get realistic terrain in there too. By importing .fbx files, which you mentioned DEMS, they can be generated from those. So you get accurate 3D landscapes.
Definitely. And once you have that 3D stage set in Roblox, the real magic, the interactivity, comes from scripting with Lua.
Yeah.
Make things react, respond to clicks, and crucially for us, work with that geographical data.
Like we learned about this thing called a GIS mapper module script in Roblox. It's a piece of Lua code that does something really clever. It takes real-world coordinates, latitude and longitude, and it figures out the exact corresponding spot within your 3D Roblox world. It's basically translating the map address to a 3D location.
That's the essential translation layer, right? Connecting the flat map coordinates to the 3D space accurately based on real geography.
And using scripts like that, you can then automatically place virtual markers, like digital pins, at all those specific geographic points in your Roblox scene. So if RStudio gave you a list of interesting locations,
The script can just loop through and pop a marker down at each one on the 3D landscape. No manual placing needed.
which is huge. It lets you populate your 3D world with data points tied directly back to your original analysis.
Exactly.
But it gets even cooler. You can use other little scripts in Roblox, local scripts and things called click detectors, to actually let the user add labels in real time. Imagine clicking on a 3D building you placed and typing in its name, and boom, the name appears right there.
Yeah.
That's real-time interaction. You're basically inputting data directly into your personalized 3D GIS.
It totally transforms it from just a static model into a dynamic tool you can engage with, add information to.
And a real strength of Roblox, I think, is how easy it is to share what you make. Few clicks, and you can publish your 3D GIS program. Make it accessible for others to explore together. Think about teachers creating virtual field trips.
Oh, absolutely. That ease of sharing and collaboration makes Roblox really compelling for, education or community projects using 3D GIS.
Okay, let's switch gears slightly to Unity. If Roblox is the accessible, maybe more collaborative starting point, Unity is often seen as its more powerful professional big sister, let's say.
Yeah, definitely capable of the same digital twinning feats, but it offers perhaps a wider range of features, often used for projects needing higher visual fidelity or more complex interactions.
But the core idea is similar. Those 3D models from Blender, informed by your RStudio data, you can bring those into Unity as well.
The asset import process is pretty standard across many engines.
The main difference you hit is the programming language. Unity uses C# instead of Lua for controlling everything.
Right. C#'s it's a very widely used, powerful language, gives you a lot of capability for complex scripting.
And we saw a similar script example there too, didn't we? A PO manager script in Unity does basically the same thing as the Roblox one. It takes Latlon data, creates interactive markers in the Unity scene.
Yeah, it's about automating that placement of georeferenced objects accurately within the Unity world.
And Unity has this cool feature called raycasting. Think of it like shining a virtual laser pointer from your mouse click into the 3D world.
Okay.
Raycasting lets the program know what that laser hits, so you could use it to let user click on the 3D terrain and say, I want to add a point of interest here, then maybe type in a name and details, again, building that interactive, personalized GIS experience right in Unity.
It enables that direct interaction with the scene geometry. It's a
Yeah.
really intuitive way for users to input data or query features just by clicking.
There was also mention of a little helper script, lockmesh.cs in Unity. Seems useful.
Yeah, just a simple script to stop you from accidentally dragging or moving your main terrain mesh around while you're working. Important for keeping your geographical base accurate.
Good point. And for making it feel more, well, immersive, especially if you're sharing these Unity projects online using platforms like spatial.io, you can integrate Ready Player Me avatars.
Oh, right. Those customizable 3D avatars of yourself.
Yeah, adds that personal presence, makes it feel more like you are in that virtual environment exploring the data.
Definitely enhances the feeling of presence and collaboration.
And speaking of spatial.io, much like Roblox, you can actually publish your Unity creations. Using their Spatial SDK, you can publish to the free tier of spatial.io, so others can jump online, explore your 3D GIS world interactively.
Yeah, spatial.io is really geared towards that sharing and collaboratively experiencing 3D spaces made in Unity. Another great way to get your work out there.
So, okay, we've traced this incredible path, studio analysis, minus 3D interactive environments in Roblox and Unity. But what's the absolute key that unlocks this for, say, a teacher or a student who has basically zero programming background?
Well, that brings us right back to our digital allies. Those AI language models like ChatGPT, they are absolutely the linchpin, making this whole sophisticated process accessible.
Exactly. These AI tools can help generate the code you need in all these different languages we've touched on. RScript for the data side, maybe some Python for prepping data, Lua for Roblox, C# for Unity.
You don't need to be fluent in all of them, or even any of them initially. You can essentially describe the function you want. Make a marker appear at these coordinates, or let the user click this building and type a name.
And the AI gives you code snippets.
Yeah, relevant code snippets in the right language for that platform. It's like having a patient coding tutor on call 24/7.
It really democratizes the whole thing, doesn't it? Creating custom 3D GIS programs isn't just for specialized developers anymore. It's genuinely becoming possible for teachers making lessons, students exploring local issues, just anyone with a curious mind wanting to see spatial data differently.
Absolutely, that accessibility is huge. It empowers so many more people to engage with spatial information and maybe even contribute new ways of understanding our world.
So, stepping back, what are the bigger implications here? What does it mean, potentially, that people can create these personalized 3D GIS tools?
Well, if you think about big challenges like envisioning sustainability, this kind of tool could empower communities, help them engage with spatial planning, visualize potential changes, understand impacts in a much more intuitive visual way.
Yeah, I can totally see that. Or imagine interactive learning environments, students exploring, say, historical changes in their town in 3D, or taking virtual field trips to places they can't physically visit. The educational potential seems enormous.
It facilitates a much deeper grasp of complex issues, environmental, social,
Yeah.
because you're not just looking at data, you're actively participating with it in 3D space.
It feels like a real shift from passively consuming static maps to actively creating and interacting with these dynamic 3D representations. That's where those aha moments really hit, right? When you realize, wow, I can build my own sort of QGIS, but in a game engine, and really feel the spatial relationships.
That hands-on interactive piece is key. It fosters a much more intuitive, meaningful understanding of geospatial concepts.
Okay, so wrapping up this deep dive, we've charted this really exciting journey, starting with data analysis in our studio, moving through to building interactive 3D GIS environments in both Roblox Studio and Unity. And crucially, we've seen how digital allies, AI tools, are making this accessible like never before.
I think the core takeaway has to be that individuals, even without deep programming expertise, now have this incredible potential to create their own customized 3D geospatial tools. It just opens up so many avenues for learning, exploration, and, well, understanding.
And here's something for you, the listener, to mull over. Just imagine the possibilities for education, for community planning, for your own personal explorations. What happens when anyone can build and interact with their own 3D versions of the world? What unique perspectives, what innovative solutions might bubble up from this democratization of geospatial tech? Maybe think about how you could apply these ideas, these tools, to things that spark your interest. Thanks for joining us on this deep dive.